because usually it's easier to kind of reduce all this to this than it is to try to build that up. Does that make sense to you? That we got stuff we can do over here. What can we do over there? What's something we can do? Okay, 1 minus cosine squared is sine squared. But that little group of identities that you're referring to there, those are called the Pythagorean identities. And they all only involve squared functions. So if this had a squared on it, I would absolutely change it to sine squared. But there is no identity if it's not squared. Okay? So remember, if you're using 1 plus tangent squared is secant squared, it's squared. 1 plus tangent does not equal secant. It has to be squared. Okay? Rory.
Turn the minus cotangent into minus cosine of sine.
Absolutely, that's what I would do. And here's the deal. You get no points for doing nothing. Right? You got to do something. So when you look at this problem, you don't have a lot of options. But one option you have is exactly what Rory said. Change the cotangent into cosine over sine. That will be easy for you because you will have memorized that cotangent is cosine over sine. Now the next step becomes obvious. Usually after you do the first thing, you kind of get the flow going. What do I have here? This is a fraction minus a fraction. What do I do when I have to subtract fractions? You find a common denominator. So you're going to write this as 1 fraction. And the common denominator is going to be 1 minus cosine times sine. That's your common denominator. So in order to put them together into 1, they have to both have that denominator. Okay? So this one needs a sign. So I put a sign on the top and the bottom. That one needs a sign. Now, see how it now has the common denominator. All good. This one needs a 1 minus cosine. Right? So, now they have the same denominator, so let's look at the numerators. Looks like I've got sine squared. Now be careful here because this is going to be a distribute, right? So it's going to be minus cosine times 1, so that's minus cosine. And then it's going to be minus cosine times minus cosine, which is plus cosine squared. Oh my gosh. Something there should be like in your face. These two make a 1. That's one of the things you need to get memorized. In fact, sine squared plus cosine squared equals 1 is called the fundamental trigonometric identity. It is a big deal. Sine squared plus cosine squared is 1. So now you have 1 minus cosine, because this makes a 1, over 1 minus cosine times sine. Now usually I'm wigging out when you want to cancel with additions and subtractions, but it's okay as long as you cancel out the whole thing. You can't cancel parts. You can't cancel the cosine and the cosine, for example. That won't work. But if you're canceling out the whole thing, it's fine. So now I'm left with 1 over sine. Well, shoot, guys, what's 1 over sine? Cosecant. And isn't that what you wanted to end up with? Done. Accomplished. Good. I should have been keeping track of the ones I've done. Let me pick another one. That was 22 off the sheet, but that's really not important. So you just need to know how to do this. Because we are just going to throw a couple at you tomorrow. Okay, let's let's try this one. And again, I think I've said this before, if you are uncomfortable with the thetas, feel free to change them to x's or something else. I don't want you losing any sleep or getting unfocused because you're uncomfortable with the variable. Use whatever variable you want. Okay. Now, one thing I'd like you to kind of notice, if you haven't already, is that I think we'll probably mess around over here. And that means this is what you want to end up with. And everything here is a secant. So it would be great if I could change everything into secants. So think about what you have memorized. What do you know about tangent squared? Do you have an identity that involves tangent squared?
Yeah.
You do. And in fact, I'll write it over here to the side, that identity links tangent squareds and secant squareds, right? So that's like perfect. What if 1 plus tangent squared is secant squared? That's what's in my brain. What do I put in for tangent squared? What is just tangent squared? Secant squared minus 1. So I don't have to memorize that. I memorize this and then rewrite it however I need it. So tangent squared is secant squared minus 1 and then minus 3. Can I do the same thing with this one? So secant squared minus 1 minus 5 secant plus 7. Now, obviously we're going to have to do some reducing somewhere along the line because there's no squareds in this, but at least it's all secants now. All right, so on top I've got secant squared minus 4, right? You're going to lose a point if you don't put a variable in. So I don't care if it's x's or thetas or whatever, but if you just do this, you're going to lose a point. Make sure you have your variable attached. So the top is secant squared minus 4, and the bottom is secant squared minus 5 secant plus 6. Can I cancel that 4 and that 6? No, 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 no. Because why? See all these adds and subtracts? When you have adds and subtracts, you can only cancel if you can cancel out a quantity. You can't cancel a piece here and a piece here, ever. Whether it's trigonometry, regular algebra, whatever, you can't do it. Okay? So if I want to cancel, which I think I have to cancel, I need to be able to cancel quantities. What does that mean I need to do here then? Factor it. I need to factor that. How does secant squared minus 4 factor? Plus 2 minus 2. That's exactly right. It's the difference of squares. It's the difference of squares. Now the bottom isn't quite that easy, but it factors also. The bottom is a little quadratic trinomial. It factors just like this. Anybody see how it factors? You have a minus 5 and a plus 6. How's that going to factor? Rory?
Just do secant minus 3 and then secant minus 2.
That's exactly what you do. Because if Rory FOILed that back together, he would get secant squared minus 3 secant minus 2 secant. There's this 5, and then plus 6. Perfect. Now, Mr. Kunkel, see this guy right here and this guy right here? Now I can cancel them because I'm canceling out an entire factor. Think about it like this. Don't cancel unless you can factor. Okay? If you don't have it factored, don't cancel it. Cancel it after you factor. Okay? All right. That was a good one. Let's let's try this one. Now, there is nothing wrong with taking a stab and having to redirect. Nothing wrong with that. So you might want to make sure you have a pencil with an eraser tomorrow. Although, if the quiz is almost over, don't erase everything, because if you have nothing written down, I can give you no points. I can give you almost all the credit if you're going on the right track. Okay? Well, who's got any kind of idea at all? Anything at all that pops into your head? Rory, you're on fire today.
You factor the numerator? Yeah, like rearrange it and factor.
You put 1 minus sine squared x, and then you take that out.
Okay, so I'm hearing two different ideas. So Rory's idea is that is a quadratic binomial. So he wants to try something like this. And that's perfect. I don't think it works though, because it would have to be 1 and 1, and it would have to be sine and sine, one positive and one negative, and I don't think that adds up to a sine in the middle. Do you see what I'm saying? Your idea is perfect, it's beautiful, and it's worth a try. It just doesn't factor. So that would be a wrong turn. That would be a good attempt, partial credit for sure. Doesn't work though. All right, so Jesus, what were you saying? You were saying something different.
I was saying like you know how you're can we split it up like into 2 parts?
Uh-huh.
So,
What
like,
are those?
One part has like sine over cosine, so you can make it a tangent, and you can have like a 1 minus sine squared x.
Okay, you're exactly right, but I gotta, before I split it like you're suggesting, I have to make that connection. So 1 minus sine squared, now, you don't have to memorize that. If you've practiced a lot, you already have it memorized, but what you have to remember is you have an identity that has sine squared in it. That's what's memorized. Now that can be rearranged however you want. If you subtracted the sine squared over to the side, you would have 1 minus sine squared. And what would that equal? So Jesus is saying, rewrite this as cosine squared minus sine, or plus sine, excuse me, over cosine. So these two make a cosine squared, then I have my plus sign. Now he says, uncommon denominator it. Split this apart and think of it as cosine squared over cosine plus sine over cosine. We don't do that very often. We normally put them together, but would everybody agree that this is the same as this? It's a legal move, we just don't do it very much. Now, cosine squared over cosine will cancel and give you cosine, and sine over cosine will give you tangent. So you did it. Took a little bit of creativity, but you did it. All right, let's try one more. that seems almost impossible. But remember, you have to do something. So what's something that we can do? Sure. And you're thinking to yourself, but Mrs. Ford, I want to end up with a secant. You're right. Give me another idea. What else can I do?
Turn the cosine into, or
Turn the cosine into 1 over secant? I could do that, right? And that sort of sets me on the path of getting this. Either one is fine. I think I'll do that because it does make sense. So I have 1 plus secant over 1 over secant plus 1. Remember, secant and cosine are reciprocals. So 1 over the one of them is the other one. 1 over cosine is secant, 1 over secant is cosine. That's the way it works with reciprocals. All right, that's called a complex fraction. And anytime you have a complex fraction, you need to simplify it. You can do that however it works for you. The quickest, fastest way is to multiply every single piece of the fraction by the common denominator of all the little pieces. So when I say all the little pieces, this big black fraction, 1 is a piece, secant's a piece, 1 over secant's a piece, and 1 is a piece. The common denominator of those 4 things is secant. So I'm going to multiply everything by secant, because that will get rid of the little fraction. So now I have secant plus secant squared over 1 plus secant. Now, this is where I'm at, and that's where I need to go. Would you agree things have to cancel out? I've got too much. And I told you a minute ago, you really can't cancel until you do what first? Factor. So does that factor at all? We can take out a secant. So if we take out a secant, we'll be left with 1. Remember, when you take out the whole term, you have to put 1 plus secant. And that's over 1 plus secant. Right? Well, what happens? Cancel the whole shebang, and we are left with secant. Okay? Every one of these problems is different. So it's not like we can practice 15 times and you'll know exactly what to do. Everyone's different. Let's talk about some of the strategies, though. Tomorrow you walk in, I hand you a piece of paper, it's got one of these on it. What are some things you're going to be thinking about and looking at? Like here. Grace said, well, I got to end up with this, so let me change this into a secant. That was a great strategy, right? That was a great strategy. Then we had an algebra problem. We have a complex fraction, so we got rid of the denominators. So we have to do algebra sometimes. Factor, distribute, collect like terms, regular math stuff. Then we noticed that, whoa, this is way bigger than what I want. There's only 2 ways, or I guess 3 ways, to make big things condense. One is to use an identity. Like if you have a sine squared plus a cosine squared, you make it a 1. That's simpler. Another way is to factor and cancel. And the other way is to collect like terms. If you have a negative tangent squared and a positive tangent squared, you can add them together and they disappear. But somehow you have to make the big thing into a little thing. So in this case, we factored and canceled. Seems like several of our problems we factored in. So think about that as something to do. All right, we gotta get through a few more of our notes, and then if we have time, we'll come back. What I plan to do, I kept track of the ones I've done. So today I also have D period, so I will do a different set of problems with them, but I'll video it. So if you want to see some extra practice problems, that will be videoed for you to watch. I don't think any of you ever watch the videos because they have like one view, but they're there for you if you want them. All right, so just to clarify, because we started using some other identities yesterday, or the day before, whatever day that was. Just to clarify, kids, what do you have to have memorized for tomorrow? The first 8. That first column, the first 8, okay? We've been using some other ones. We're gonna use a bunch today. These you will write on a note card at some point to use. The only ones you have to memorize so far, there are going to be 3 more you memorize, but the only ones so far are those 8. All right? So here we go. I am, in my notes, I am in 5.3. I am in 5.3, and I am on problem C. All right, so you got your colored sheet out because you don't have the identities memorized for this one. This is exactly the kind of problem you're going to have on the quiz, but this one uses identities that I didn't ask you to memorize. So this will obviously not be on the quiz, but the process is on the quiz. You're probably going to change all this into this. Would you agree with me? Okay, so I look at this, and it's the sine of an angle minus an angle. Do I have a simplification for that? I do. On the paper, there are u's and v's, but the idea is the same. So when I expand this, it's going to be sine of the first, cosine of the second, minus cosine of the first, sine of the second. So all of this is this. Does that make sense to everybody? It's easier for me because I have them memorized. You're trying to juggle back and forth between the paper, but it's cosine sine minus cosine sine. All right, so then I've got plus. Now I'm going to do exactly the same thing, only it's the sine of u plus v, which is sine of the first, cosine of the second, plus cosine of the first, sine of the second. We didn't talk about this, but did you notice that the 2 formulas here are exactly the same, except for the sine in the middle? And that's true for the cosine formulas too. They're the same except that middle sign. Okay, well, what do you notice now? We've got it all expanded. What do you notice? We're going to combine like terms. And that one will cancel, right? Because one's positive and one's negative. The other 2 are exactly the same, so I can add them. So one of them and another one of them is just going to make 2 of them, isn't it? And that's what you wanted to end up with, so it's good. We're done. That seems pretty easy. Well, we just finished 5.3. I don't know how I got off. I've already got 2 assignments due on Friday, so we'll make this one due on Monday. 5.3 will be due on Monday. If you want to turn them all in together, that's fine. But I'll be due on Monday. Oh, wait, no, I've already assigned 5-3, right? Yeah, it's due Friday, yes. So 5-2 I extended just because it's harder. So yeah, it's due Friday.
So they're both due Friday?
They're both due Friday, yep, yep,
This board,
yep.
is the quiz tomorrow on 5.1?
Well, 5.1 uses those same identities. It's just more simplifying. So 5.1 and 5.2 are really the same thing.
So it's gonna be over that?
Yes, it's going to be over what we just practiced. The quiz tomorrow is over those things we did at the beginning, the whole beginning of the period. Huh?
Only those things?
Only. That's it. And I haven't even written a quiz yet. It'll be 1 or 2 of them. Okay, that's it. So the quiz on Friday, or the quiz tomorrow is 1 or 2 problems like we did at the beginning of the period, not this. What? Oh, probably. Unfortunately. All right, this is a good time, and when we come back, we'll start 5-4. So you can go ahead and go to lunch.